Hello everyone. So again we are here with the subject machine learning, module 1 data pre-processing, lecture 3, which will deal with data cleaning. Yeah. So starting with the introductory part, as the name already defines what is data cleaning. Data cleaning is the process of fixing or removing incorrect, corrupted, incorrectly formatted, duplicate, or incomplete data within a dataset. When combining multiple data sources, there are many opportunities for data to be duplicated or mislabeled. The definition itself says that why do we need this data cleaning? It is because when we actually gather the data from various sources, so there is the chance that there can be some duplicate data, or maybe possible that we can miss some sort of data, or also there can be some sort of human errors of typing as well. So in that case, we need to deal with such corrupted data in order to bring the data into a particular format so that we can feed it to algorithm in order to get our desired output with accuracy. So if data is incorrect, outcomes and algorithms are unreliable, even though they may look correct, right? So even though the algorithm is right and it is giving output, but we can say that it may not be accurate until unless the data is correct or well organized and formatted, free from errors. So there is one absolute way to prescribe the exact steps in the data cleaning process, because the process will vary from dataset to dataset. But it is crucial to establish a template for your data cleaning process, so you know you're doing it the right way every time. Same thing that I have already discussed with you, that there is no one absolute way to be provided to all the challenges. There are some steps for each different type of challenges that we have seen in our previous videos. So exact step in the data cleaning process, because the process will vary from dataset to dataset, but it is crucial to establish a template for your data cleaning process, so you know that you're doing it right way every time. Here you can see the steps which are involved in data cleaning. The removal of unwanted observations, which we do not require such data. We need to remove that, because it will be keeping that. The first thing, it will be reducing the quality of our data, and as well as it will be increasing the size of the data. So it becomes very great necessity to remove such unwanted observations. Fixing structural errors, syntactical errors, as well as semantical errors, we need to fix that. Managing unwanted outliers. Outliers means if there is something in the range, the data is expected to be in the range between 1 to 20, and you have your data as 100. So 100 will be considered as an outlier. So in that case, where we need to have the input between 1 to 20, in that case, the 100 will be an outlier. So we need to deal with such outliers in order to get an accurate data output. And the last one is handling missing data. what will we be doing if we have no data or the specific tuple is empty? So we need to handle that. So in upcoming slides, we'll see how we are dealing all these four types of challenges specifically. The first one is missing data. While we see missing data, we need to follow these three steps, either of these three steps. Dropping observations with missing values. The fact that the value was missing may be informative in itself, thus in the real world, you often need to make predictions on new data, even if some of the features are missing. The first thing is what we can do is we can just let it go. We can let it go that specific tuple for that observation. Or the second thing, imputing the missing values from past observation. Again, missingness is almost always informative in itself. You should tell your algorithm if a value was missing. Even if you build a model to impute your values, you are not adding any real information. You are just reinforcing the patterns already provided by other features. And the third part is replacing it with either the mean, mode, or the median. If some of the values are missing for that particular column, we can go ahead with the mean of that column and we can fill that value over there, or we can go ahead with the mode of the value or the median. This is how we deal with missing data. What we'll be doing if we have a noisy data? First method to deal with noisy data is binning. Binning is a way to group a number of more or less continuous values into a smaller number of bins. For example, if you have data about a group of people, you might want to arrange their ages into a smaller number of age intervals. In that case, data binning or the bucketing is a data pre-processing method which is used to minimize the effect of small observation values. Original data values are divided into small intervals known as bits, and then they are replaced by a general value calculated for that bit. This has a smoothing effect on the input data and may also reduce the chances of overfitting in the case of small data sets. Let us say that with an example. There are two methods of dividing data into bits. Sorry. Equal frequency binning. Binning have an equal frequency. An equal width binning. Bins have an equal width with a range of each bin are defined as minimum plus W plus 2W and so on. Where W is max minus min up divided by number of bits. Equal frequency. Now let us check. We are having an example. We have input values 5, 10, 11, 13, 15, 35, 50, 55, 72, 92, 204, 215. Now we can see how many numbers are there. 1, 2, 3, 4, 6, 7, 8, 9, 10, 11, 12 numbers. So for the 12 numbers, if we go ahead with the equal frequency binning, so there will be 3 bins with 4 numbers in each. So the first one is 5, 10, 11, 13. The next will be 15, 35, 50, 55. The last bin will be 72, 92, 202, 215. Now equal width. For equal width minimum, how we are finding max minus 1, max is 215, minus 5 is 210, and we need to have how many bins that we are dividing with that. So ultimately we'll be getting 5, 10, 11, 13, 15, 35, 50, 55, 70, 90, 204 and 215. The number of bits depends upon you. The last is so you can see that this is the input that we have given for equal width, and 5, 10, 11. We have 210 was the 210 was the W is equal to 210 upon how many number of bins you really want. So you can see there are 3 if we consider 3 bins. So that would be 7. So we are having minimum 5 plus 7. 1, 2, 3, 4, 5, 6, 7, 8, 9. Sorry, that is for they're doing for equal width bin. So while retrieving the equal width here, we have been given with input 5, 10, 11, 13, 15, 35, 50, 55, 72, 92, 204, 215. In that case, we have just seen that the formula for equal width is W is equal to max minus min upon number of bins. So basically what we do, the maximum number here is 15 and the minimum is 5. And the number of bins, let's suppose we want 3. So 25 minus 5 upon 3 is 70. So all the numbers which are 75, sorry, that will be 75. So all the numbers which are under 75 will be here in the first bin. Then again, the remaining numbers will be 92, 204, 215. So 215 minus 92 divided by 3 will give you 184. So all the numbers which is less than 184 will be in one bin, which is only 92. So 92 is in the another bin. And for the last, again, same thing we will do. 215 minus 204 divided by 3. So if we say this 215 minus 204 divided by 3, we get the number 4, which is like the remaining numbers will be in the last bin because we have only 3 bins. So 204 and 215 will be in the last bin. Now next is a regression. Regression takes a group of random variables thought to be written, predicting by, and tries to find a mathematical relationship between them. This relationship is typically in the form of a straight line that best approximates all the individual data. This we will be studying in algorithm as well in very much in detail. Clustering is another type of algorithm, but still we can use it for data cleaning. Clustering is the task of dividing the population or data points into a number of groups such that data points in the same groups are more similar to other data points in the same group and dissimilar to the data points in other groups. It is basically a collection of objects on the basis of similarity and dissimilarity between them. We can say that there are scattered data, and with this scattered data we have clustered, and also we have removed some sort of data. So ultimately that has been followed as data cleaning. So that's it for this video lecture, which contains the part of data cleaning. Thank you.